Hello students, today we will discuss about the lesson light, reflection and refraction. As we have discussed reflection in the last video, now today we will discuss about the process of refraction. What is refraction? When light enters from one medium into another medium, the direction of propagation of light in the second medium change. When a light enters from one medium to another medium, then direction of propagation of light in the second medium changes. That is here. This is the medium. Here above this is the rare medium or air, and this is the denser medium or water or glass or anything else. This is the rare medium in which particles are very far away, denser medium in which particles are very close to each other. When a ray falls on any reflecting surface, that ray is called incident ray. When a ray falls on the or strike on the reflecting surface, that ray is called incident ray, and after refraction, this ray is called refracted ray. When ray enters from one medium to another medium, then it will change the path. The ray should go along this path, but here it changes the path and shows the process of refraction. This is called a refracted ray. And perpendicular along the reflecting surface, this perpendicular is called the normal. Angle between the normal and incident ray is called angle of incidence. Angle between the, that is the angle between normal and incident ray, that is called incident angle. And angle of refraction, this is the angle of refraction. Angle of refraction is the angle between the normal and reflected ray, and refracted ray is called angle of refraction, that is angle of refraction R. When any incident ray moves, then it moves from the rare medium to denser medium, then it will move towards the normal. It will move towards the normal. Or if it will move from the denser to the rare medium, then it moves away from the normal. Now, laws of the reflection. Here you can see the incident ray, refracted ray and normal all lie in the same plane. First rule is incident ray, refracted ray and normal all lie in the same plane. Second rule is sin I, angle of incidence, and sin R, angle of refraction. Both are the constant. Ratio of sin I by sin R is equal to constant. Now, refractive index. The constant of the ratio sin I by sin R is called refractive index, and it is denoted by the N. The constant of the ratio sin I by sin R is called refractive index of second medium with respect to the first medium, and given by the N to 1. N is the refractive index of 2 is medium 2 with respect to the medium 1. If light travels from a rare medium 1 to the denser medium 2, then the refractive index of denser medium with respect to the rare medium is given by N2 by N1 is equal to N21. That is the refractive index of medium 2 with respect to 1 is equal to sin I by sin R. Now, refraction through rectangular glass slab with the parallel faces. This is the glass slab and this is the rare medium or air. This is the denser medium or glass. When a ray falls on this glass surface or slab surface, this is called incident ray. Incident ray. And this angle between the normal and incident ray is called incidence angle. Angle of incidence. Now, when a ray moves from rare to denser medium, then it will bend towards the normal, not move straight. It will bend towards the normal. This is called refracted ray. Refracted ray. And this angle is called angle of refraction. Angle of refraction. Now, when this ray moves from dense, now this is the denser medium and this is now air or rare medium. This is the rare medium. Now, when the ray moves from denser to rare, then it will bend away the normal. It should go according to like this, but now it bends away the normal. This is called emergent ray. Emergent ray. And this angle is between the normal and emergent ray is called emergent angle. This is the process of refraction in a rectangular glass slab. Now what is lens? Lens, when two spherical or plane reflecting surfaces are joined together, then they form the lens. It is the transparent and two spherical plane reflecting surface joined together. This is called lens. It is of two types, convex and concave. Now the different rules that are followed to draw the ray diagram. First is a ray of light from the object parallel to the principal axis. Just like the reflection, first rays of light goes parallel to the principal axis, will pass through the focus only. Will pass through the focus only. A ray of light passing through the principal focus will goes parallel to the principal axis. And third is a ray of light passing through the optical center of the lens will emerge without any deviation. It will pass in a straight path. It will not deviate anywhere after reflection. We will discuss about the important terms that are associated with the lens. This is the convex lens. And if we complete this sphere, there are the two hollow spheres. It has the two hollow sphere and this is the focus of this sphere and this is the focus of this sphere. Now the optical center. At the center of the lens, at the point O, the central point O on the principal axis of the lens through which incident ray of light passes undeviated. It will not deviate and pass straight. Pass straight, undeviated. This is called optical center. Now the center of curvature. The center of the sphere, that both the sphere has the center and the center of the sphere whose part is a spherical surface. This is the spherical refracting surface of the lens and the center of this sphere is called center of curvature. And both the lens have convex lens have the two spherical surfaces, so it have two different center of curvature C1 and C2 lies on the either side. Now radius of curvature. Similar to the center of curvature, here are the two spheres. Here are also the two radii R1 and R2. Radius of the sphere from which the spherical surface of lens is made, and each lens has two radii R1 and R2. And when we join this line C1 with the C2, this is called the principal axis. Now the principal focus. When a parallel beam of light coming from at any position, then after refraction, it will pass through the focus only, and this point is called focus. When a parallel beam of light is incident on one of the spherical surface of the convex lens, the rays after refraction meet at a fixed point is called focus. Now the focal length. Focal length is the distance of the focus from the optical center. Distance of the focus from optical center. This is called the focal length. Now we will discuss about the ray diagram for various objects in the convex lens. This is the convex lens. This is f1 to f1, f2 to f2. First position is when the object is at infinity. Rays are coming from the infinity. Mark the center point. It will help in the optical center, and these rays are coming from the infinity, and after refraction they will go from the focus, and the image formed is real, inverted and diminished size. When the object is at infinity, then according to the three rules, the rays coming parallel from the according to the first rule, rays come parallel to the principal axis, and after refraction passes from a point that is called focus and passing through the optical center undeviated. Now at the second position, draw the convex lens, mark f1, f2, f1 to f1. Now the object is at before the 2f. According to the first rule, the rays would go parallel to the principal axis and then passes from the focus and then passes from the optical center without any deviation. This is the image. The image formed is real, inverted and small size than the object. Now at the third position, draw the convex lens, f1 to f1, f2 to f2, and when the object is here before 2f1 and the here object is at the 2f. Now at 2f, first rays goes parallel to the principal axis, then passes from the focus and then passes from the optical center, and the image formed at the 2f. Here, if object is at the 2f, the image is also at the 2f. Now, image formed is real, inverted and same size of the object. Now, next is after the 2f, or you can say after 2f, before f, or in between 2f and f. Between 2f and f. Now, put the object here. First goes parallel to the principal axis, then passes from the focus then passes from the optical center, and if the object is after 2f, then image will formed after the 2f. Image is real, inverted and large size. Then the object. Now next is when the object is between f and 2f, now object is at the f, or focus. Now rays goes parallel to the principal axis and passes from the focus and then passes from the optical center, and it will look like at the infinity. Image is formed at the infinity. Real, inverted and large size. Now next position, draw the convex lens, mark its focus and center of curvature here, and put the object after F or between optical center and F, between O and F, between optical center and F. Now first, according to first rule, the rays goes parallel to the principal axis and after refraction passes from the focus. Now according to second rule, goes from the optical center undeviated and it will meet at the back side and the image formed on this side, and this image is virtual and erect. Object is standing and image is also standing, virtual, erect and highly enlarged. Now the image formed by concave lens. Image formed by concave lens. This is the concave lens. If you will complete the circle, then focus of this lens is on this side and focus of this lens is on this side. Now, if the rays are coming from the infinity, then the rays goes parallel to the principal axis and then after refraction they will go like this and the focus of this circle is this. The rays seems to meet here at the focus. Then the image formed is virtual. This is the image, virtual, erect and diminished, very small size, diminished. Now the other position is when the object is placed at any position, then first rays goes parallel, then after reflection goes back and rays goes from the optical center undeviated, and this is the image. Image is virtual, erect and diminished size. Mark the arrow to show the direction of the rays. Lens formula. If U, V and F are the object distance, image distance and focal length. If U is the distance of the object and V is the distance of the image and F is the focal length, then the lens formula is 1 by F is equal to 1 by V minus 1 by U. Now what is the magnification of lens? Magnification of the lens is the ratio of the height of the image to the height of the object. Height HI by HO. O means object. Height of the image and height of the object. And V is the image and U is the object. Magnification for real and inverted image is taken as negative. Magnification of real and inverted image is negative and virtual and erect image is as positive. Now what is the power of the lens? Power of the lens. Ability of the lens to converge or diverge the ray of light is called power and it is equal to the reciprocal of focal length. P is equal to 1 by F. Reciprocal of focal length is called power of lens and its SI unit is diopter. Its SI unit is diopter and measured by the dioptometer. If the focal length is expressed in meter, then power is said to be 1 diopter. When the power is said to be 1 diopter, if the focal length is expressed in 1 meter. Power of the convex lens is taken as the positive and concave lens is taken as negative. Thank you.